Right now, Earth feels perfectly balanced. Gravity is strong enough to keep everything grounded, but not so strong that movement becomes difficult. The atmosphere is thick enough to support life, but not so dense that it becomes crushing. Everything about the planet seems fine-tuned for stability, as if any major change would disrupt that balance completely. Now imagine something different. Not a new planet, not a distant world, but this one, Earth, suddenly becoming twice as large. Not over millions of years, not through gradual growth, but instantly. The radius doubles, the volume increases dramatically, and with it, everything that depends on size begins to change. At first glance, nothing seems obviously wrong. The sky is still there, the ground still feels solid, and the environment appears familiar. But the difference reveals itself quickly, because when a planet's size changes, gravity changes with it. If Earth's radius doubles while maintaining the same density, its mass increases by a factor of 8. That means surface gravity becomes roughly twice as strong. Every movement becomes heavier. Standing up requires more effort. Walking feels like carrying constant extra weight. The human body is not built for this. Muscles strain under the increased load, joints experience greater stress, and even simple actions like lifting an arm or taking a step require significantly more energy. Over time, this would make normal movement exhausting, especially for those not adapted to higher gravity conditions. The atmosphere responds as well. With stronger gravity, gases are held more tightly to the planet, leading to a denser atmosphere. Air pressure at the surface increases, making breathing feel different. Oxygen is still present, but the weight of the air itself becomes more noticeable, creating a sense of resistance with every breath. Weather patterns intensify. A denser atmosphere can hold more energy, leading to stronger winds, heavier storms, and more dramatic weather systems. Clouds form differently, precipitation patterns shift, and the dynamics of the atmosphere become more complex. The oceans deepen. With a larger planet and more gravitational pull, water redistributes across the surface, potentially creating deeper basins and altering coastlines. Waves behave differently, and the energy within the oceans increases, influencing climate and weather in new ways. Flight becomes more difficult. Aircraft require more lift to overcome the increased gravitational force, making takeoff and sustained flight more challenging. Even birds, evolved for Earth's current conditions, would struggle to stay airborne under the new weight. As the hours pass, the effects become more noticeable. Structures designed for current gravity begin to experience additional stress. Buildings, bridges, and infrastructure must support greater weight, and while some may hold initially, others begin to fail under the increased load. Meanwhile, the planet's interior is also affected. Increased mass leads to higher pressure within Earth's core, potentially increasing geothermal activity. Volcanic activity may become more intense, and tectonic movements could change as the internal dynamics of the planet adjust to its new size. By the end of the first day, it becomes clear that this is not just a larger Earth, but a fundamentally different world, one where every system, biological, atmospheric, and geological, has been altered by a simple change in scale. As days turn into weeks, the consequences of a larger Earth continue to unfold, revealing how deeply size influences every aspect of a planet's behavior. The increased gravity does not just affect movement. It reshapes ecosystems, technology, and even the long-term evolution of life itself. Human bodies begin to adapt, but only to a limited extent. Over time, stronger muscles and denser bone structures may develop in future generations, but the immediate effects are strain and fatigue. Daily life becomes more physically demanding, and activities that once felt effortless now require careful management of energy and effort. The atmosphere, now denser and more compressed, changes how sound travels, how heat is distributed, and how weather systems evolve. Storms become more powerful, with greater energy stored in the air. Wind speeds increase, and precipitation becomes heavier, leading to more frequent and intense extreme weather events. Transportation systems must adapt to the new conditions. Ground-based travel becomes more energy-intensive due to increased friction and weight, while air travel becomes less efficient and more limited. Rockets, which already require significant energy to escape Earth's gravity, face even greater challenges, making space exploration far more difficult. The oceans, influenced by stronger gravity, may experience changes in circulation patterns. Currents shift, affecting global climate systems and altering the distribution of heat across the planet. Marine life must adapt to new pressure conditions, particularly in deeper regions where the increased gravity amplifies existing effects. Plant life also changes. With stronger gravity, the structure of plants must support more weight, potentially leading to shorter, sturdier growth forms. Tall trees may become less common, replaced by vegetation adapted to withstand the increased load. Animal life follows a similar pattern. Creatures evolve to be more compact and robust, with stronger skeletal structures to support their weight. Movement becomes more energy-intensive, influencing behavior, migration patterns, and survival strategies. Geologically, the increased mass of Earth affects its internal dynamic. Higher pressure within the planet's interior may lead to increased volcanic activity and more frequent tectonic shifts. The surface becomes more dynamic, with landscapes shaped by forces that are stronger than before. Over longer timescales, the planet settles into a new equilibrium. Life adapts, systems stabilize, and Earth becomes a different kind of world, one defined by higher gravity, denser air, and more intense natural processes. The most striking realization is that size alone can transform a planet completely. Doubling Earth's size does not simply make everything bigger, it changes the rules that govern how everything works, from the smallest biological processes to the largest planetary systems. In the end, the scenario reveals how finely balanced Earth's current conditions are. What feels normal is the result of specific parameters, and even a single change, like increasing the planet's size, can create a world that is still recognizable, but fundamentally different in every way that matters.